Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Eventide by Phoenix Aki, and here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 in each row, column, and 3x3 box without repetition. We have consecutive pairs, or white Kropke dots, where digits separated by a white dot must be consecutive. So, for example, if this were, say, a 6 here, this would have to be 5 or 7 to make sure that these digits are consecutive because there's a white dot between them. And finally, we have killer cages, where digits in dotted line cages must sum to the number in the top left corner of the cage. And digits may not repeat within a cage, but that's okay because they couldn't repeat anyways because they're all in the same row or column. So, for example, if this were, say, a 4, this would have to be an 8 because these two digits must add up to 12 because they have a 12 in the upper left-hand corner, and those are the only two digits in the cage. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, these three digits add up to 7, so they have to be 1, 2, and 4 for three unique digits to ever add up to 7. Well, that means 1, 2, and 4 are eliminated as possibilities for the rest of this column. So that leaves 3, 5, 6, 7, 8, 9 here. And the only digits consecutive with 1, 2, or 4 would be 3 or 5. And they can only be consecutive with 2 or 4, not 1. So the remaining digits in this box then are 3, 5, 6, 7, 8, 9. These two digits adding up to 14 are 5, 9, or 6, 8. Okay. This digit is consecutive with two other digits, so it cannot be 9. And if we had an 8 here, that would guarantee this one of these digits would have to be 9, but those 8 and 9 would eliminate all possibilities for this 14 cage here. So this can't be 8. Okay. If this were 5 or 6, so if we had 5 here, that would guarantee 6 is one of these consecutive digits, which is not possible then, because if this is 5, this would have to be 6 and 4, and that would eliminate all possibilities for this 14 cage. Same with this being 6. If this is 6, this is 5 and 7, which would eliminate all possibilities for this 14 cage. So this has to be 3 or 7 here. 3 can be next to 2 or 4. 7 can be next to 6 or 8 here. So those are the possibilities there. This adds up to 14. It's 5, 9, or 6, 8 here. These add up to 12. Cannot be 3 and 9 because of 9 in the row. So this has to be either 4, 8, or 5, 7 here. If these add up to 6, it's either 1, 5, or 2, 4. If say this was 2, 4, though, that would mean this cannot be 2, 3, 4 as a triplet here. It'd be 6, 7, 8. But then this digit also has to be consecutive with two other unique digits. And we don't have 2, 4, 6, 7, 8 available. 1, 3, and 5 are not consecutive with each other. Neither is 9. So this cannot be 2 and 4. It has to be 1 and 5 here. Which means this has to also be 2, 3, 4. Or you could have... So you could have 2, 4 around here with 3 there. Or this could be 7 or 8 here with 7 with 6 or 8 here. Or 8 with 7 or 9 here. We don't know which. Anyways, 1 and 5 cannot appear anywhere here. 1 has to be one of these remaining digits here. And if it is, it has to be consecutive with another digit because it can't be here. So 1 would have to be with the 2. So we have a 1 guaranteed in one of these cells, which means if this is 1, this has to be 2. If this is 1, that's 2. If this is 1, that's 2. If either of these are 1, this can't be 1 because that's consecutive with 2 unique digits in the box. So if this is 1, this has to be 2 there. This digit, so one of these is guaranteed to be 2, 3, and 4 here to be consecutive. So this can't be 2, 3, 4. It cannot be 1 or 5. It either has 6, 7, 8 here, or 7, 8, 9, or 6, 7, 8 as possibilities. So therefore, 7 and 8 cannot be here. Therefore, this is 6 or 9 there. These digits have to add up to 9. And that the possibilities for 3 unique digits adding up to 9 are 1, 2, 6, 1, 3, 5, or 2, 3, 4. Well, if this is 1, 3, 5, that would eliminate all possibilities for that cell there. So this cannot be 1, 3, 5. It's 1, 2, 6 or 2, 3, 4. Either way, we are guaranteed a 2 here. All of these digits are consecutive. Does that tell us anything? I don't really know. We just know this digit cannot be consecutive with the others. So say we had a 2 here. That means one of these digits in row 9 would have to be a 1, but then that would be impossible because 1 is only consecutive with 2, and all of the remaining digits are consecutive with another digit. So this cannot be 2. Can this be 4? If it's 4, we have the same problem. We have to have 1, 2, and 3 be in the remaining digits, but only 2 can be consecutive with 1 or 3, and it can only be consecutive with only one of them. And 3 no longer has 4 available then to be consecutive with it, and then so 1 or 3 is going to be stuck not being next to a Kropke dot. So this cannot be 4. So this is 1, which means this cannot be 1 here. Okay. These digits are consecutive. You cannot have a 2. What about consecutive digits here? 3, 5, 6, 7, 8, 9 is only consecutive with 2, 4, 5, 6, 7, 8, 9. But this can't be 2, so this is 4 through 9 here. This is 4 through 9 there. In row 9, since 1 is the only digit that's not consecutive with another digit, 9 must be with 8, 2 must be with 3, 4 must be with 5, 6 must be with 7 to be consecutive. This obviously can't be 8 and 9 because that would eliminate all possibilities for this 14 cage here. So this could be any of 2 through 7. This digit, again, is only consecutive with 3, 5, 6, 7, 8, 9. So it could be 2, 4, 5 through 9 there. Same with this 2, 4, 5 through 9. What else do we have? These 3 digits are consecutive, so are these 3. These digits are consecutive. It cannot have a 2, so you can't have 1, 2 here. It cannot have a 9. So it could be 3, 4. It cannot be 4, 5, because that would eliminate all possibilities for this 12 cage here. It could be 5, 6, though. It could be 6, 7. No, 7, 8, because that would eliminate all possibilities for this cage there. And this can't be 9 because of 9 in the row. So we have 3, 4, 4. It cannot be 4, 5. 3, 4, 5, 6, or 6, 7 here. Interesting. So either this is 3, 4, or it contains a 6. This is 3, 4, or it contains a 6, which means the rest of the box cannot contain a 6, and it can't be 2 or 9. So this has to be 1, 3, 4, 5. We are guaranteed an 8 here. And then this could be 5 or 7. But 8 has to be here, which means this can't be 8 here. These digits are consecutive also. We know out of these 3 digits, there must be some that are 1 or 2. This can't be 1 here. So if this is 2, 3, 4, obviously 1 can't be here, 1 can't be any of these, so 1 would have to be here. Therefore, 6 can never be here, because if this is 6, that would mean this is 2, 3, 4, but then there's no place for 1, because 1 is consecutive only with 2, and these can't be consecutive with 2. And this can't be either. So if this is 2, 3, 4, this is 1. This has to be 6 with 5 or 7. Which makes this a 4-8 pair. So this is guaranteed to be 1 in that case. 2, 3, 4 forces this to be 5. So this does not have 4 or 8 available. It does not have 5 available, nor 2, 3, or 4. So this wouldn't this have to be 6, 7? No, that doesn't work. Okay. So again, if this is 2, 3, 4, no, it would be 6, 7. Yeah. This would be 1. 2, 3, 4 eliminates 3, 4 as a possibility for this consecutive digit, so it'd have to be 5, 6, or 6, 7. Either way, it would eliminate 5, 7 as a possibility here. So this would be 4, 8 here. This cannot contain 1, 2, 3, 4, or 8. And the 2, 3, 4 eliminates 3 here, so that's 5, which means this can't be 5. So this cannot be 8 and 9. You don't have 1, 2, 3, 4 available, or 5. So this has to be 6, 7 then in that case. So we are guaranteed if this is not, this is 2, 3, 4, this is 1, and 6, 7 here. Which means 6 cannot be any of these digits here, because if this is 1, 2, 6, obviously it can't be 6 here. Okay. So if this is 1, 2, 6, this cannot contain a 6 in it, so this must be 3 and 4 consecutive, which makes this a 5, 7 pair. So this cannot contain 1, 2, 5, 6, or 7. Therefore, that could be 8, 9 here. Or it could be 3, 4, or 4, 5. Well, it can't be 4, 5 because of the 5 here. So this 5, 7 pair. So that could be 3, 4 there in that case. And we don't really know what this is in that case. Okay. So either way, in this right central box, 7 has to be one of these or one of these. 9 can't be here, so that means this can't be 5 there. Oh, this can, well, yeah, it could be anything there. So, we are guaranteed either this is 3, 4, in which case this is 5, 7, or this is 6 with 5 or 7, which would make this 4, 8. So we cannot have 4 remaining in row 4. So we have 1, 2, 3, no 4, 5, 6, 7, 8 as possibilities, which is pretty broad still. Hmm. Oh, this is interesting. So if we cannot have 6 or 8 here, because if we have 8 here, 9 has to be one of the remaining digits in row 1, and it's consecutive with another digit, but we already have an 8 there. Same thing with 6. So the similar situation to this, right? In row 1 as in row 9. If we have 6 here, the 7, 8, and 9 have to be consecutive with another digit, but 8 can only be consecutive with only one of them, which is 7 and 9. So if it's consecutive with a 7, the 9 doesn't have one that to be consecutive with. If it's consecutive with a 9, the 7 doesn't have anything to be consecutive with if this is 6. So this cannot be 6 or 8. It's 5, 9 as a pair, which eliminates 5, 9 in the rest of the column. This can't be 5, so this is 3. No 5 or 9 here. So these can't be 3. 3 eliminates 3 here, so that's 7, which is consecutive with 6 or 8. That means this can't be 6, 7, and 8. It's 3 with 2 and 4. That leaves this digit as a 9. This can no longer be 2 here because of 2, 4 pair in the box. So this can't be 1. This can't be 1 because of that. These digits are consecutive, though. So we have 1 and 2 there. These digits have to be 1, 2, 3, 4 remaining in this upper central box. 1 through 4 is only consecutive with 1 through 5 here. This can't be 2, 3, or 4 because of the 2, 4, 3, 2, 4 pair and the 3 in the box. So if this is 1, this has to be 2. If this is 5, this has to be 4. This is 1, 2, 3, 4, which is consecutive with 1 through 5 also. No 1 or 5 is available here, so this is 2, 3, or 4 there. So we're either missing a 5 or a 9 in the rest of row 1. If this is 5 and 4, but the problem, if we have 5 and 4 here, the problem is 1, 2, and 3 are no longer, have to be in row 1 next to a white crop key dot, which is not going to be possible. Because 2 would have to be consecutive with 1 or 3, but that would eliminate the other digit from having anything to be consecutive with if this is 5 and 4. So this cannot be 5 and 4. It must be 1 and 2 here, which means this can't be 1, 2 as a pair. It's 3, 4 as a pair. 2 eliminates 2 in the rest of the box and column. 1 eliminates 1 here. This can't be 1 here. 3 eliminates 3, 4 here. So this is 1, 2, 6, which eliminates 2 and 1, 2, and 6 in the rest of the box. So no 1 here. This can't be 6 So it cannot be 5 and 6 or 5 and 6 and 7. So this is 3 and 4, which eliminates 3, 4, and the rest of the box. So this is 5, 7, 8 as a triplet, which eliminates 5, 7, 8 in the rest of the row. Also, this 7 eliminates 7 here, so it's 6 and 8 here. This can't be 4 and 8. It's 5 and 7 as a pair, which eliminates 5 and 7 in the rest of the box and row. So this can't be 5. This cannot be 5, 7. This can't be 5, 7. There's no more 8 available and no more 3 available. 8 eliminates 8 in the rest of the box. 3 eliminates 3 here. So this cannot be 3, 4 anymore. It can't be 6 with anything. It's 8 and 9 here, which eliminates 8 and 9 in the rest of the box. Well, this can't be 5, 7, or 8, 9, and this, so therefore this must be 4 here, which eliminates 4 in the rest of the row, so this is 5, 7. 5 and 7 are only consecutive with 6 or 8. So this must be a 6, 8 pair here out of the remaining digits. That eliminates 6, 8 in the rest of the box. So these digits are all odd, which is consecutive only with even digits. So this is 2, 4, 6, 8. Same with this. This 4 eliminates 4 here, so that's 2 and 4. 2 eliminates 2 here, so it's 6, which makes this 1, which makes that 2. 1 eliminates 1 here. Where is the 1 in this upper central box? It must be here. This can't be 2 or 6, so this is 8, which is consecutive with 7 or 9. No, actually, it has to be specifically with 9, because all of these digits are consecutive with another, so 9 has to be with 8. So this is 9. This cannot be 9 and 8. No more 9s here because of 9s in the boxes. Remaining digits of the central box are 3 and 4. This 3, 4 pair eliminates 3, 4 in the rest of the column, so this can't be 3, it's 5 or 7. Therefore, where is the 3 in this lower central box? It must be here, which means... No, this can't be 3 or 4. It's 4 or 9. Apologies for that. I made that. That was a pretty bad mistake. This is 4 or 9 remaining in the central box. 9 eliminates 9 here, so that's 4, which makes that 9. 4 eliminates 4 here, so that's 3, which makes this 4. 4 is consecutive with 3 here. Remaining digits of row 5 are 1, 2, and 3. This can't be 1 or 2 because of 1, 2 in the column, so that's 3, which makes this a 1, 2 pair here. Okay. Remaining digits of... So this is 3 digits that... 1 digit's consecutive with 2 others. So it could be 5, 6, 7... 6, 7, 8, or 7, 8, 9. Either way, 7 has to be one of these 3 digits. So this cannot be 7 here. This could be 5, 6, 8, 9 here. 5, 6, 8, 9 here. This can't be 6 or 8, though. So we have a 5, 9, 5, 9 pair in row 2, which eliminates 5 and 9 in the rest of the row. So these can't be 5 or 9. Therefore, we have a 6 or 8 here, which means this cannot be 6, 7, and 8. It has to be 5, 6, 7, or 7, 8, and 9. So either way, this is 5 or 9 here, which is consecutive with 6 or 8, which is consecutive with 7 here. 7 eliminates 7 here, so it's 5 and 7. We have a 5, 9, 5, 9 pair in row 1. So this must be 7 with 6 or 8 here. Remaining digit 3 eliminates 3 here, so this is 4 and 3. This can no longer be 4. This can't be 3. So 2 and 3 are consecutive. So 2 cannot be here. 4 and 5 are consecutive in row 9. So this cannot be 5 here. This is 6, 8 as a pair here, which eliminates 6, 8 as a possibility for this 14 cage. So this is 9, this is 5. This can no longer be 4 and 5 to be consecutive here. We have a 2, 3, 6, 7 quadruplet in row 9, which eliminates 2, 3, 6, 7 in the rest of the row. So this is 4, 5 as a pair. 5 can't be here because of 5 in the column. So that's 4, which makes that 5. This can't be 5 anymore, so that's 9, which is consecutive with 8 and consecutive with 7. 9 eliminates 9 here, so it's 5 and 9. This can't be 9, so it's 5, which makes this a 6 because this can't be 8. 9 eliminates 9 here, so that's 8 and 9. Remaining digits of column 7 are 7 and 9. This can't be 9 because of 9 in the row, so this is 7, that's 9. This cannot be 8 here, so this is 6, 7 as a pair. Remaining digits of row 2 are 2, 4, and 8. No 4 here because of 4 in the column. 5 eliminates 5 here. 5 also eliminates 5 here. So this is 1 and 5. Therefore, this can't be 5 anymore. Where's 5 in row 5? It has to be here. Okay, we are guaranteed one of these 2 digits is a 2. One of these 3 digits is a 6. So the rest of this lower left central box cannot be 2 and 6 or 5 and 9. So we have 1, 3, 4, 7, 8 available. This can't be 4 here because of 4 in the column. No 3 here because of 3 in the column. No 7 here because of 7 in the row. Well, where is the 7 in column 3? Has to be here. So that's 7, which means none of these are 7. Where is the 7 in this lower central box? It has to be here, which is consecutive with 6, which means this is 2 and 3 here. It eliminates 3 in the rest of the box. 6 eliminates 6 here. 2 eliminates 2 here. No 2 here. This can't be 7. So one of these 2 is going to be a 4. Which means this can't be 4. That's 2, which makes that 4 there. We have a 6, 8 pair here, which eliminates 6 and 8 in the rest of the row. So this is 1, which makes that 2, which makes that 8. 8 eliminates 8 here, so it's 4, which makes that 2. No 2 here. 4 eliminates 4 here. 1 eliminates 1 here, so this is 8, which makes this 4. 8 eliminates 8 here, so it's 7 and 8. 7 eliminates 7 here, so it's 6 and 7. 6 eliminates 6 here, so it's 1 and 6. 3 eliminates 3 here, so it's 5, which makes that 3. 5 eliminates 5 here, so that's 7, which makes that 5. 5 is only consecutive with 6 out of 6 or 8. So that's 6, this is 8, that's 6, this is 8. We have 2 and 3 remaining in row 7. This can't be 3 because of 3 in the column, so that's 2 and 3 there. 2 eliminates 2 here, so it's 1 and 2, which leaves this as a 6 and this as a 1. Yeah. I don't know. I don't know if I attacked this in quite the right way. I felt like, yeah, I needed to attack these row 1 and row 9 earlier. I don't know if I would consider this very easy, though. It's not necessarily trivial to deduce what these digits can be. Once you understand the logic behind it, you can get it, but it takes a while to get there. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.